Okay, optimization is dead. We should all be doing something else. Software engineering seems to be popular.
Prosting's law?
Yeah, Probstein's law, yeah. Okay, so here's just one slide of, I'm sure we can add lots to this. So one is the whole issue of if you're doing online feedback-directed optimization, there's a whole bunch of issues that come up. You know, one is what optimization should you be performing online? Another is how should you use it? We just talked about a client may not want to use a big heavy JIT, it might want to offload stuff. Do you want to have counters to basically trigger your optimization? Do you want to have some kind of modeling of what's going on? When should one VM switch from some form of VM to FDO to another one? So if you're doing speculation, you've probably profiled something and said, okay, I think this is a good idea. I'm going to speculate, but what happens if your profile changes? First of all, you know, what do you do? Well, okay, reprofile and then re-speculate. And then the other question is, how do you know when it changes? So I think that's a whole area there. Yeah, I guess I mentioned theoretically grounded selective optimization is basically, yeah.
So, for me, I think, one nice outcome of this workshop would be to go from a list there to a prioritized list, and to have people come to some, general agreement about what the really important things are to do, what's left to do, and obviously there'll be some difference of opinion, but I think that there's a lot of things there, and they're all different, and you may or may not get value out of them. Right. So it'd be interesting to know what people think.
Yeah, that's a good idea. Yes, 2 slides.
So when I saw the myth, optimization is dead, I thought it was not that we didn't think we could get it to run any faster, it's just it doesn't matter. It's already fast enough that they're not going to enable a new class of applications by making it run a little bit faster.
Right.
So you need to rebut that myth. You need to rebut that.
Yeah.
Well,
so I think
priorities too, right?
Right.
You put the most important things at the top of the list, and then you ask what percentage of improvement are you going to get out of that #1 thing?
Right. And so what Vivek was mentioning earlier, and Mark mentioned this as well, was that sort of higher level programming models are maybe much bigger wing there.
I was going to say that's no context. If you've ever seen a lot of these J2EE creatures crawling along, the problem isn't in the VMs. It's in the 42 layers of glop that finally gets further glop with yet another JCA connector on its very final way out. Yeah.
I think the problem is even worse. I mean, it's not just optimization is dead. I mean, at least in universities, people think programming languages and compilers is dead. I mean, try creating a new faculty slot for. It's a boring topic, and it's people think just like operating systems research is basically dead at universities. At least it's very difficult to get new faculty positions for this because people just think it's not a sexy topic. It's been along for too long anyway, and we've got Microsoft who's going to do it for us, right?
Mark?
There's another thing you didn't list here, which Ben reminded me by mentioning Probstein's law. What Todd observed is the hardware people have done a much better job of speeding things up than the optimization people. The hardware people are now telling us they're going to stop doing that.
But I think there's a different way to interpret Probstein's law anyway, which is the hardware people had this, 40% a year, because there's 3% a year you get at this architectural level, and 4% you get at this architectural level, and 6% you get at this below the architectural level. And the 4% a year you get at the program optimization level in the compiler is just one of the architectural levels. And you shouldn't be ashamed of that.
Yeah, the frequency is going to cease improving.
Right. So that's one of the architectural levels.
And yeah, but I mean that's been a lot of what's happened, and I think it will change to some extent the way machines are designed. And it will change the trade-off, and it will change our understanding of what we're allowed to do in the future. Yeah. Because a fundamental fact of life for the last probably 100 years, literally, is going to change.
Yep.
But it is because of the fact, like what Mendel mentioned, that performance is not as critical for end users as other sort of facilities. That is one of the reasons.
Well, you haven't, as Doug says, you haven't tried using a J2EM.
Yeah.
Well,
We are good at sucking up everything the hardware people have given us.
Yeah.
And we've done it, and we will continue even when they stop giving it to us, which is going to cause a problem.
So
Because
just
we don't
one-
realize it.
The last slide,
Sorry.
I'll come back to this guy. And this one is not terribly controversy. Those grad students who felt they couldn't do any kind of innovation in this area are completely wrong. I mean, folks in this room certainly have lots of things to add to this list in terms of open source infrastructure. And let me know which ones I've missed. Now I'm done. Stop.
Okay.
Yeah,
With the
I-
moderators.
You were talking about profiling earlier. Is there any information that you really need to get by program implementation as opposed to performance counters? It seems to me that if you look at some of the newer architectures, you can increasingly get all of this information without actually implementing the code and possibly cheaper. I don't understand the trade-off there.
Well, it depends on what level of information you want. If you want type information, for example, you're not going to have that from the hardware. If you're profiling, receivers, virtual dispatch is one example. But I mean, I agree.
Well,
I think
you can get the you can potentially get the call edge there, right? So that sort of indirectly gives you you get edge profiles, which allows you to reconstruct the type information. But
yeah, I like that trend. I'd like to see more of it in the hardware, and I think that where we're going, where hardware is providing better profiling mechanisms, I think that's the right direction. I agree.
It's also portability, I guess, is one of the reasons why
Yeah.
software things. Not all current hardware have features.
Yeah, and the hardware and the OS has to support it as well.
Yeah.
And you have the problem of correlating any of that information back to the program representation that the compiler is ultimately going to optimize.
Yes,
You know,
yeah.
reactively optimize.
In order to
Hopefully a quick about this thing. One of the reasons that that enterprise stuff runs so slow is there's an amazing amount of reflection going on in that code. And that's an area that not too many people in this room have put on high priority.
My priority would be getting rid of all that reflection.
Doing a good job optimizing.
Understanding why it's there and what it's doing and making it faster.
Okay. Anything to add to this?
What was the last topic you wrote?
Optimizing
I have optimizing reflection.
Yeah, why not?
I think the optimization is dead. Conversation probably has more.
What about
legs to it.
exceptions? I want those optimized too.
Shouldn't be programming exceptional.
How about a whole session complaining about Visual Basic exceptions?
So, Michael, related to this optimization dead, I mean, I guess the question, can the VE community help bail out the hardware people now that they've lost frequency scaling?
Okay.
So put that one at the top of the list. Right?
Right,
Anything else?
okay.
Don't think it's the right question.
they still won't pay you
It's only the frequency that scales. That's right.
pay does not scale.
No, I understand that. I just.
Okay, but it'll be fun.
Okay.
Did you want to make an announcement?
Yeah, so I'll switch hats now, and I'll. So lunch is now, and then Bob's going to tell us about what happens after lunch.
Yeah. So we